Good morning, students. In the last class, we have completed our. In the last classes, we have completed our first unit, and this class we are going for the second unit. So, in which we are going to discuss about the characteristics of op amp. So, in the last class, we have discussed in the last unit we have discussed about op amp and its internal blocks and what are the different circuits we are using. That internal blocks we have observed that. And in today's class, we are going to see about the integrated circuit. So, in this second chapter, we are going to discuss about the characteristics of op amp. Mainly, what the op amp will have, what are the different parameters the op amp will have, and how to obtain those parameters. We are going to see in this chapter. So, before going to that, today in the today's class, we are going to discuss about different fabrications of an op amp, different types of fabrications of an op amp. So first we are going to discuss about the integrated circuit. So here you can see that IC. So IC is nothing but we are going to place the different circuits what we have discussed in the last class. That is two differential amplifiers, a level translator, and as well as a push-pull amplifier on a single chip. So those circuits consisting of both passive components as well as active components. We have seen that. That is, those circuits is having transistors as well as resistors. You can see there. Already we have discussed about those circuits. That is differential amplifiers consisting of active elements as well as passive elements. And these we are going to place on a small base. So small base means small base like structure. So placing on a small base is nothing but IC, integrated chip. Integrated means nothing but we are placing several circuits in the same place. So that is said to be integrated. So because of this, placing several circuits on the same base and doing experiments with that, so the circuit will become simple. And because of this ICs, so we nowadays we are using a mobile phones, so which is having many ICs in that, and they are very small in size. So because of this ICs only, so electronic components are compact, so such that we can carry them to anywhere. So these are the advantages you can see because of this IC. Small size is very small, cost is less, and lightweight. There will be less weight also. So as it is an IC, it will take low power, that is consumes low power, and coming to the speed of operation, it will be fast. So these ICs are divided into two types: digital ICs and linear ICs. As you have studied in your STLD subject or digital IC application subject, there you are going to study about the digital ICs. So those are nothing but multiplexers, decoders, encoders. So different circuits are there like logic gates. So these all are comes under digital ICs. And second thing is linear ICs. So in this subject, linear IC applications subject, so we are going to discuss about this linear ICs. So like our op amp, operational amplifier, and we are going to use this op amp in timer ICs, and also we are going to use these in voltage control oscillator applications, different types of modulators. and different types of mm, VCO, voltage controlled oscillators, and we are going to use this for phase lock loop also, which is used for demodulation of FM signals and modulation of FM frequency modulation, that is of FM signals. So there we are going to use that PLL. So there we are going to use, in that we are going to use the linear ICs. So the classification of ICs are two types: digital ICs and linear ICs. So before going to the technologies used for fabricating ICs. So what are the different technologies used for fabricating the ICs means monolithic technology, thick and thin film technology, and hybrid technology. These are the three technologies which are used for fabricating the integrated circuits. So in monolithic technology, again, it is divided into two types. That is unipolar and bipolar. Unipolar means having only single polarity. Bipolar means it is having dual polarity. That is double polarity. Bipolar is nothing but what we have studied about BJTs, bipolar junction transistors, which constitutes both a P-type as well as N-type semiconductors. Whereas unipolar means it consists of only N-type or P-type semiconductors. So under unipolar, there will be two types, that is a MOSFET and a junction FET. Metal oxide semiconductor field effect transistor, MOSFET means, and junction FET. We have studied about this junction FET in our UDC subject. And coming to bipolar, there are two types, that is a PN junction and dielectric isolation. PN junction, as you know, that is a diode and a BJT, bipolar junction transistor. And dielectric isolation means dielectric is nothing but where capacitance exists. So that means when we are going to join two semiconductor materials, there will be a gap between two semiconductor materials. So that gap provides two conducting plates separated by a dielectric material, which acts as a capacitor. So that is nothing but dielectric isolation. And thick and thin film technology, hybrid technology. So coming to this monolithic means a single stone. So here you can see that monolithic means a single stone. Mono means single. Lithic means it is a stone. So on a single stone, we are going to manufacture this IC. That means we are going to place all the circuits on that on a single stone. So it is called as monolithic. So these are of two types. That is a can type and a plastic package. Can type, you can see here, it will be looking like a can. So it is nothing but as we have seen in the laboratories, that bipolar junction transistor that will be in a steel can, you can see, or field effect transistor, as you have observed in your electronic devices and circuits laboratory, EDC lab, nothing but transistor. So that will be the transistor will be fabricated in a small can type structure. Okay, small steel can type structure, like that can type structure we are going to manufacture this op amp. So there will be placed a single silicon chip and terminals will be projected outside. In a can type structure we are going to manufacture this IC. And second one is plastic package. That means plastic, with the help of plastic we are going to place the chip inside a plastic, and we are going to coat around that with a plastic. So and we are only projecting the terminals outside. So this is nothing but plastic package. So plastic package. So I will show you that. Okay, I will show you that next time. Thick and thin film ICs. Next one is it uses glass or ceramic surface. So what about this thick? Second one is thick and thin film type. So it uses a glass or ceramic surface. That means which glass or ceramic substrate is not going to conduct. It acts as a insulator, nothing but. So on that insulator, we are going to fabricate our circuits. So it uses a glass or ceramic surface and deposits a film of a conducting material. So we are going to deposit a conducting material on that glass or a ceramic substrate, and we are going to we are going to obtain, we are going to place our circuits on that glass or ceramic substrate. So the resistors. So on in this, the resistors and conductors are fabricated by controlling the width and thickness of the films. So as we have said that by conducting material, by placing a film type conducting material on a glass substrate, we are going to manufacture that. So by varying the width of this glass type material, so we are going to construct the resistors as well as conductors. So if we want to, that means if we want to place a resistor, then that we are going to make the thickness of the film more, like that. So how the capacitors are fabricated? The capacitors are fabricated by sandwiching. That means sandwiching, you know that. So placing two breads up and down, and we are going to place a material in between the two breads, you know that. Like that, we are going to sandwich a film of insulating oxide between two conducting films. That means, so we are going to place two metals in up and down, and we are going to place a insulating material in between those two metals. Then we know that, as we know that the capacitance is nothing but a two conducting plates separated by an insulating material. So here the insulating material is oxide metal, nothing but oxide, and we are going to place a metal, two metals, and in the between those two metals we are going to place a insulating material, that is oxide. So like this, we are going to fabricate the resistors, and we are going to place the capacitors on a single chip using this thick and thin film ICs. Thick and thin. You can see here itself, thick and thin. Thick means thick film. That means the film width will be more, and thin means the film width will be less. So usually digital ICs are fabricated using this technology. So this thick and thin film technology is used in MOSFETs, metal oxide semiconductor FETs, and this is used in VLSI technology. This is also used in VLSI technology. So mainly these are used in digital ICs, fabricating the digital ICs. This technology is mainly used. And next, coming to hybrid technology. So this is nothing but a multi-chip integrated circuit. So multi-chip means we are going to place different types of chips on a single chip. So multi-chip means we are going to place different op-amps on a single base is nothing but a multi-chip technology. That means we are going to place several circuits on a single base. Several circuits on a single base. So that is nothing but a hybrid technology. These have better performance than monolithic circuits. The fabrication process is too expensive because as you know that monolithic means we are going to place two or three circuits like that on a single chip. But here, coming to the hybrid technology, we are placing many circuits on a single chip. So placing many circuits on a small place is very complicated. So the fabrication process is also expensive when coming to the hybrid technology. Next, we are going to discuss about the operational amplifier packages. So packages of operational amplifier. So how this operational amplifier is manufactured, we will see. So there are three types: metal can type, as we have discussed, that metal can type; dual inline package. Dual inline means that will be equal and inline. That means that will be projected on the terminals of the op amp will be projected on two sides of the op amp. And third one is a flat package. This is also dual inline package is also called as DIP, dual inline package, and flat package. Flat package means flat means that will be flat on a flat surface. We can see that. So flat package, the IC will be flat. That means we are going to place on a PCB, printed circuit board. You know that. So just we are going to place that on a PCB, and we are going to solder that. So there is no need of attaching that to the uh, attaching the IC to the PCB. The packages contain single, dual, and quad op amps. So these packages consists of single op amp or a dual op amp. That means on a single chip it is consisting of two op amps, and quad op amps. Quad op amps means on a single chip it consisting of four operational amplifiers. So typically these packages have 8 terminals. These packages have 8 terminals. So CAN and dual inline package will have 8 terminals and 10 terminals to the flat package, and some CANs also having the 10 terminals, and 14 terminals ICs are also there. That is in dual inline package as well as flat package. So here you can see this is the CAN type, 8-pin metal CAN type, in which it is having 8 terminals. So that the terminals are given the numbers also. You can see here 1 2 3 4 5 6 7 8. So and where one is offset null, and second one is inverting input, third one is non-inverting input, fourth one is negative supply, fifth one is offset null again, and sixth one is the output, and seventh one is the positive supply, and eighth one is no connection. So not needed this terminal. So eighth one is no connection. This is the metal can package. Whereas dual inline package. So dual inline package, it is also having 8 terminals, but dual inline means these connecting pins are on both sides of the ICs. You can see here on the left side as well as the right side. You can see here. So the number starting from here 1 2 3 4, and it is coming like a U-turn 1 2 3 4 and 5 6 7 8, like U. How we are writing U, in that way the pins will be. So and you have to keep in mind this there will be a small glitch will be there here. So by placing this glitch upward, we are going to uh, identify the terminals. So by placing glitch upward, so this will be 1 2 3 4 and 5 6 7 8. So first one is offset null, inverting input, non-inverting input, and negative supply, offset null, output, positive supply, and no connection. Let us see these ICs. So see here. So these are dual inline package ICs. So like this, the IC will be like this, and the pins will be projected downwards like this. So these are dual inline packages. So you can see here. So this is a 555 timer IC. We are going to discuss about this IC also. Dual inline package. This is a to be dual inline package. And coming to metal can. So we'll see a metal can also. So this is a metal can type. So you can see here, these are the can types, metal can type. So this is metal can type. So you can see here, this is the metal can type. So in a can type structure, we are going to fabricate this IC, and these are the terminals projected outside. So this is metal can type. And next, coming to flat package, flat package IC. So this is the flat package IC. So as you have observed, these types of ICs in your mobile phones also. This is a flat package. The pins will be what we are going to connect the pins, that will be flat. So we are going to place this on a printed circuit board, and we are going to just do it soldering. So these are three types of packages, different packages. And we have seen the metal can package, we have seen the 8-pin dual inline package, and also we are having this 14-pin dual inline package. This is nothing but 14-pin op amp, so in which it is having 14 pins. So here you can see, so first from first pin onwards up to 14th pin. So it is having the same terminals of the 8-pin op amp, that is offset null, inverting input, non-inverting input, positive supply, negative supply, and offset null output. So like that, this is a flat package. As we have seen now, a flat package, the pins will be flat, that is the terminals will be flat. So this is all. This is the 10-pin IC in a flat package. These are the different packages for an operational amplifier. So three different packages we have seen. And now, so who are the manufacturer companies for manufacturing these ICs? We are going to discuss about that. Now, the first one is the Fairchild. Fairchild is going to manufacture these ICs, and they are giving a number mu A. So this is their representation, that is mu A they will give on the IC itself, mu A 741. So 741 is a op amp. 741 we are calling that as operational amplifier. And this is a Fairchild, how they are giving on the operational amplifier. So you can see that also Fairchild op amp. Fairchild ICs. Mu A. See here. So like this, mu A. There will be written mu A. Then this is manufactured by Fairchild. You can see that that will be manufactured by the Fairchild. And next, National Semiconductor. So like that, National Semiconductor is another company which is going to manufacture the ICs, different types of ICs, and they will give their representation as LM, LH, LF, and TBA. So our op amp will be given as LM741 op amp. And coming to the another one, that is Motorola. Motorola is one of the company, and their representation is MC, MFC. So here you can see, for an op amp they will give MCI 741. So another company is there, that is RCA. They will give CA and CD as their representations, and this is our operational amplifier IC, CA 3741. And Texas Instruments is another one. So they will give the representation as SN. So and op amp is nothing but SN 52741. And Signetics, they will give N by S or NE or SC. They will give either N or S or NE or SC. So N5741 is an op amp, and Bud Brown is another company. They will indicate that BB741 is an operational op amp. So these are the different manufacturers, different types of manufacturers is going to fabricate this operational amplifier or digital ICs or analog ICs. So they will indicate that their representation on the IC itself. So by seeing that IC, you can say that which company is going to manufacture those ICs. These are some of the major manufacturing companies of integrated circuits. And coming to next thing is, so how this op amp is having, that is op amp is going to work in different temperature conditions. So here you can see for a military grade, so we are going to use an op amp. That means military grade means military is going to work at different temperature levels. That means they are working either at minus degree centigrade, that is negative temperatures, as well as high temperature conditions also. They are working in cool areas, as well as they are working in deserts also, that is very hot areas also. So because of that, what they are using the equipment there, in that equipment, if you use an operational amplifier, it must withstand in low temperatures as well as high temperatures. So for that reason, military grade op amps is going to operate perfectly between these temperatures. You can see that is minus 55 degrees centigrade and plus 125 degrees centigrade. So up to negative minus 55 degrees centigrade, the op amp will work normally, and as well as up to plus 125 degrees centigrade, so the op amp will work normally. So these are military grade op amps, and this will be somewhat costly. Next, commercial op amps. Commercial op amps means which we are using in our laboratory purpose. We are using these are commercial op amps. So commercial op amps can withstand between the temperatures 0 degrees. That means our room temperature is around 28 degrees centigrade. So we can work, our op amp is going to work between 0 degrees and 70 degrees, maximum up to 70 and 75 degrees. So these are commercial grade op amps. And next, 741A and 741E, improved versions of op amps. These are improved versions of op amp 741 and 741C respectively, having better electrical specifications. These are having better electrical specifications like offset voltage or supply voltages or like that, better electrical specifications these are having. Next, 741S. This is also a military grade op amp with a high sleeve rate. So what is the sleeve rate? We are going to discuss in this chapter itself. I will tell next what the sleeve rate. And 741SC, this is a commercial grade op amp with high sleeve rate. So this is a commercial grade op amp. That commercial grade means what we are using in our laboratory purpose. So these are the different types of temperature ranges for an operational amplifier. Next, power supply connections. So up to now we have discussed about IC packages and different types of op amps. So next, op amp power supplies. How we are going to give the power supply to an operational amplifier. So see here, you can observe that the op amp power supplies voltages may range between. So op amp power supply voltages range between plus or minus 5 volts to plus or minus 22 volts. So minimum it will be plus or minus 5 volts, and maximum it will be plus or minus 22 volts DC, nothing more. Instead of using power supplies for an op amp, so we know that as we have discussed that for a differential amplifier, as we are using differential amplifier in operational op amp, so for that reason, it requires two power supplies. You know that. You keep it in mind. That is VEE and minus plus VCC. So negative supply is required as well as positive supply is required. For that reason, so we have to use two sources. That will be one will be positive source and another one will be a negative source. So positive source as well as a negative source. So positive supply as well as a negative supply. Instead of using two power supplies, so we are going to maintain use a single power supply, and we are going to obtain both supplies using a single power supply. That is how we are going to see now. So here we are having three circuits for that. So using a single power supply, we are going to derive two different voltages. Here you can see. So in the first circuit, in the this circuit, so we are using a voltage divider network, that is a resistor which is having a resistor combination and a capacitor combination. So these resistors acts as a voltage dividers, and these resistors are dividing this Vs voltage into two sections. So see here, Vs is the main power supply we are giving, and we are giving it to the resistor R. So we have to keep in mind one thing, this while using this circuit. So the resistance must be, that is the two resistance value must be greater than 10 kilo ohms, greater than or equal to 10 kilo ohms, not less than 10 kilo ohms. So we have to keep in that mind, because if it is less means the resistance will burn out because of that. So we must use the resistance greater than or equal to 10 kilo ohms. So this will divide this voltage into two halves. So based upon these resistances, because here we are using both resistances are equal, that is 10 kilo ohms and 10 kilo ohms. So we are going to obtain half of the voltage at this top of the terminal, and half of the voltage at this bottom terminal. You can see here, top we are having the positive voltage, and bottom we are having the negative voltage. So positive voltage as well as negative voltage. So capacitance provides the decoupling, that is decoupling for this circuit. So here it is, the middle terminal will be grounded, and here we are going to get half of the positive supply, and here we are going to get half negative supply. So with the help of these two supplies, we can connect we are using a single supply, and we are going to divide this single supply into two. So this is nothing but this is how we are going to obtain a power supply for an operational amplifier. So another method is also there for obtaining two power supplies for a single power supply, that is using Zener diode. So as we know that a Zener diode is having a capability of operating in forward bias as well as reverse bias. So by using this Zener diode, which is going to operate in forward bias condition, we are going to make a positive supply and a negative supply for our operational amplifier. So see here, this Vs is divided into two sections with the help of Vz1 and Vz2. So Vz1 is for providing a positive voltage, and Vz2 is providing a negative voltage. So this is how using Zener diode, and we are using a small resistor here, Rs. So this Rs is chosen such that it allows the Zener diode to operate in avalanche mode. So we have to choose Rs such that, so it allows the Zener diode to operate in avalanche mode. Avalanche mode means avalanche breakdown may occur due to reverse bias of the Zener diode. So we have to keep in mind such that we have to keep in mind to make this resistor, to choose the resistor such that avalanche, this it must the Zener diode must operate in avalanche mode only. So like that it will provide the two power supplies. And third circuit, so what are the drawbacks in these two circuits means, we cannot say, practically we cannot say these two resistance will be same. Why? Because we are going to take 10 kilo ohms and 10 kilo ohms, but it may not be a 10 kilo ohms, it may not, maybe a 950, that is it may be a 9.5k, it may be a 10.5k. Maybe practically this is not these two resistors may not equal. Because of that reason, this vs2 and v minus vs2 may not have the same magnitude. That is one of the drawback. And also here also vz1 and these two digital diodes may not be similar. So we think that we're to be a similar, but may not be similar. Practically it is impossible. So we are getting somewhat differences between the voltages obtained, that is positive voltage as well as negative voltage. So to avoid that, we are going to use another circuit, that is here we are using, in the place of a fixed resistor we are using a potentiometer, that is pot. So because of this, using this pot, if the voltages are we can adjust the voltages. So Vs plus Vs by 2 and minus Vs2 by 2 can be adjusted, such that we can observe that we can adjust the pot such that to obtain a uh, equal voltages, two equal voltages having different polarities. So this is how we are going to use the three circuits for our operational amplifier. So in this class, this is about this class. Thank you, students.